Hi. So anyway, for this video, we're going to be talking about the extreme value theorem. Extreme value theorem. And the idea here is this. If you have a function, it's continuous on the interval from A to B. For instance, you could do this guy. Here's A. That's x equals A. Over here somewhere is x equals B. Could be this fella. Whee! Here's A. Here's B. Whatever. Whatevs. But the idea is it's continuous. It cannot have any asymptotes, no jumps, no holes, no nada. It's got to be continuous. If it is, then maximums and minimums will occur at critical values. You're like, what is that critical value, Mr. Groom? It is where, it is the x value where f prime of x equals 0. That's a critical value. Or they will occur at endpoints. You know, A or B. And the idea here is this. So this one here, I'll draw it thusly. Whee! Hey, look over here somewhere is x equals B. That's cute. Hey, look over here. Here's x equals A. What? Hey, look, right here. Right there. Here's your critical value, yes, where the slope is equal to 0. So on this graph, where is this thing have a maximum? It has a maximum at the critical value. Where does it have a minimum? It has a minimum at x equals B. And how would I know that? Well, you've got some f of x, yes? So you're going to plug in f of A, get a value. F of B, get a value. F of the critical point, critical value, get a value. This one's obviously the biggest. This is the smallest, so it's the minimum. And this is neither. Huh. It's going to be about that easy today. Well, Mr. Groom, what if there was multiple? What if here's x equals A, here's x equals B, oh my gosh, there's like multiple. Here's 1, 2, 3. Oh my gosh, there's 4 critical values. Yeah, how about that? So let's just call that critical 1, critical 2, critical 3, maybe this one's critical 4. Of course, here's A, here's B. So if you do f of A equals a number, f of B equals a number, f of C1, f of C2, f of C3, f of C4. What you will find is, of course, that C3 is the maximum. It's the biggest of all of them. And that C4 is the minimum of all of them. Everybody else is neither the maximum nor the minimum. Okay? So let's do an example. Suppose you had a nice easy one like f of x is 3x squared plus 9x plus 7. First of all, f prime of x is equal to this. Now let's say I want to know on the interval from -5 to +6. Okay? Well, if I find the critical value by setting that equal to 0, I find that that's -9/6, which is -1.5. Okay? So if I plug them in, if I plug in f of -5, so it'd be 25 times 3 is 75, minus 45 plus 7, it's 37. And if I do f of 6, I will get that's 36, 108, 54 is 162, 169. And what if I plug in -1.5? Well, then I'll get, that's 2 1/4 times 3 is 6 3/4. And then -1.5, which is -13.5. This minus this is negative 6.75 plus that is a quarter. Okay, this of course is the minimum. This of course is the maximum. Ta-da! Let's do another one. Mercy. There you go. So if I do this, I say, all right, well, the derivative, of course, is 3x squared minus 27. So that's going to be x squared minus 9. So x is plus or minus 3. Notice that plus or minus 3 is not in this interval. So if I say to you, on this interval, where do the maximum minimums occur? Well, one's at the one end point, one's at the other end point. Okay? Now, I don't think it takes a rocket surgeon to see which one's the max and which is the min, but we'll do it anyways. So there's the 4. And there's the 7. So this one's max. This one's min. But Mr. Groove, what if we didn't put it on an interval? You mean we just let it go all the way to infinity? That's a great question. Thanks for asking. So if it's all the way from there to there, obviously you can't evaluate it at the endpoints. So if we're talking about over global maximums or global minimums, in this case, you know, a cubic function we know does this. So there is no global or overall maximums because it goes all the way to infinity. However, there are going to be maximums and minimums that are what we call relative or local max and mins. Well, the question is, which of those is these two guys? Because again, this is where our derivatives equal 0. So I plug in 3. It's going to give me 27 minus 81 plus 5 is it's negative 54, so negative 49, I think. And if you plug in negative 3, it's going to be negative 27 plus 81 is going to be positive 54, so 59. So, yeah. So this is f of negative 3. This is f of positive 3. So this one, of course, then would be our min. Our maxes, these would be, because they go all the way from infinity to negative infinity all the way across, these guys are what we call relative or local max and mins. Okay? Interesting. There's no reason why we couldn't do one of these guys. So f prime of x is 4 times 2x minus 1 minus 2 times 4x plus 1 all over 2x minus 1 squared. That's 8x minus 4 minus 8x minus 2. It's going to be negative 6 over 2x minus 1. Go ahead and set it equal to 0. I dare you. You can't. There is no place where this equals 0, meaning there are no critical points. So on this region, the max is going to be on one side, the min is going to be on the other side. And so you're going to see it's 5 over 1, so 5. So f of 1 is 5. Put a 4 in, you're going to get 16. Oh, you hooker. 16 plus 1 is 17. 17 over 7, which is less than 5. So this is the min, and this is the max on that interval. Okay. Now, let me consider that to be a continuous function. It has to be continuous on this interval. This one has a problem at x equals a half, but x equals a half is not on this interval. So we're good to go. Yo. Okay. Yeah. Whatever. So, take the derivative on this guy. I'm going to get this equals 3 sine x plus 3x cosine x equals 0. Okay. Now, not a whole lot I can do to solve that one. So, I'm going to break out the calculator. And as you know, I'm not going to be doing a whole lot with online stuff anymore. So, get used to graphing on your own calculator, I guess. Sucks to suck, I guess. Make sure you're in radians. Okay. Now, I want to tell you I want to find it between 0 and 2 pi. Okay. So, but what I'm interested in is I'm going to graph this derivative. I'm going to graph it between 0 and 2 pi. So there's a critical point, and there's a critical point. So we get 2 critical points. So F5 math, zeros. Dude, you're killing me. So 2.02. And 4.91. Those are my critical values. So what I'm going to do is I'm going to take this guy right here. I'm going to evaluate it at 0, at 2 pi, here, and here. So whip out the old calculator on my home screen. This is how I'm going to do it. You do however you want to do it. So I'm just going to do a 3x times sine x. Okay, and then I'm just going to go such that. So I'm going to do x equals 0. But that's all I'm doing is plugging in values. And then I plug in. I'm also going to plug in 2 pi. Is also 0. Meaning that probably one of my maximums, one of my minimums, going to be the other 2 points. So we'll find out though. 4.46 or something. And no, it's 5.46. And then 4.91. Negative 14.4. So this is our minimum. The minimum occurs at x equals 4.91. The minimum value is negative 14.4. The maximum occurs at 2.028, and the maximum value is 5.46. Okay? That's it. That's all. That's what you're going to be working on today. Good luck to you. I wish you well.